So today we are going to focus on solving systems that have inequalities. So part of what we're going to do is review how do we graph an inequality. So let me make this a little bit bigger and move it over and straighten it out. There we go. Okay, so remember with inequalities you have either a solid line or a dotted line, and then you shade above or below the line. So we typically have dotted lines if we have a greater than symbol or a less than symbol. That's a really sad less than, but you get the idea. Solid lines would be greater than or equal to, less than or equal to. So the key is that you've got this or equals to here creates the solid line. These ones don't have a line underneath them, so we're going to have a dotted line. It's kind of like open circle and closed circle. So then for shading, I'm going to have, let's see, a line could be going this direction, or a line could be going this direction. And I'm going to put some lines down here as well, here, and then here. So if it says y is greater than, keyword here is the word greater than. That means that you have a symbol that looks like greater than, or it could be greater than or equal to. I want you to imagine that you were dropped from the top down onto this line, from the top down onto this line, from the top to this line and top to this line. So this line is going to act like it's a mountain. And I'm going to drop you, parachute you down onto this line. And the reason why I want you to think of it that way is because some kids have trouble determining what's above a line and what's below the line. And other kids have absolutely no problem figuring that out at all. So I'm going to drop myself on all these lines. It's awesome drawing ability there. So if I'm going to shade greater than this line, I'm going to be shading up. Well, what does up mean? Up means where there is air and sunshine. So if I were you, I would add that on here. That means that you're going to shade where there is air and sunshine. So if this is a mountain right here, the air and sunshine is up here at the top of the mountain. Down here is where you would bury things. This is where the air and sunshine is. Down here is where you would bury things because this is the mountain that you're standing on. So if I'm going to shade up, which means above, then I am going to be in the shading. So here is shading up, and here is shading up. So above is not always to the right. It's up. It's above the line. Then if y is less than, you would have a symbol that looks like this or like this. So if it's less than, we're going to shade down. Shading down means where things are buried. Okay, so remember, things are buried below ground. So here you are in the air and sunshine, and below you would be down here. These are where things are buried. So that's where we're gonna shade, is down here below, down here below. Okay, so let's go ahead and try actually graphing an inequality and review that. So here we have two different, I'll make this really big, two different inequalities. So we're going to look at example 1 first. And this is in the form that we can graph in. It's in y equals mx plus b form. So let's review that again. Y equals mx plus b form, right? So remember that b is your y-intercepts. And since you're not going to be able to see my green on here, I'm going to make that black. So remember, b is your y-intercept, m is your slope. So b is your starting point. And just like on a line, we are always going to start somewhere along this y-axis here. So somewhere along here. In this case, our b is going to be -2. So I'm going to plot a point on the y-axis at -2. That's my starting point. And then m is your slope. And so remember, your slope means rise over run. So clearly I can't demonstrate what I normally do in the classroom, but remember, you want to think of slope as if you are sitting in a chair. And if you try to rise right or left out of that chair, you're not getting out of the chair. The chair is being stuck with you. When we get up out of a chair, we do not rise right or left. We go up, straight up, or we fall out of that chair and hit the ground. So the direction for rise is up or down. Then once you get up or fall out of your chair, then you run to the right or left to get out of that room. So your run is in a right-left direction. And if you think about it, I can only rise up and down on a pole. Think of rising, a flag on a flagpole. I can only rise it up and down, but I can run right or left. So we have to rise up or down, and then we have to run right or left. So in our case here, our slope, it's always the coefficient of x. Well, our slope is 3, but we want to look at it as a fraction. So I'm going to make it a fraction by putting it over 1. And remember, we can view our slope in 2 different directions. Or it's going to be -3 over -1. You have got to change both signs. So if this was positive, you're going to make it negative. This is positive, you're going to make it negative. Note that 2 negatives make a positive, so both of these have a value of +3. So what are our directions? So to rise in a positive direction means we're going up. Why? Because positive numbers are up, negative numbers would be down. So that means this rise that's negative would be going down. Then our run here is positive, so to run, we run in this direction. This is where the positive numbers are. So our run is going to be to the right 1. And this -1 run over here is going to be to the left 1. So pick one at a time. So I'm going to start here, and I'm going to rise up 3 and run to the right 1. So I'm going to go up 1, 2, 3, and to the right 1, plot a point here. Then rise up 3 to the right 1. Up 3 to the right 1. Now we're going to have to go in the opposite direction, and we're going to have to rise down 3 and run to the left 1. So from here, we're going to go down 1, 2, 3, and to the left 1, plot a point here. And down 1, 2, 3, and plot a point. So then from here, we have to decide, are we going to have a solid or a dotted line? So based upon the fact that it's less than, we know that we are going to have a dotted line. So I have a dotted line. And I'm also going to have to determine shading. Since it's less than, I'm going to shade below. Okay, so let's go ahead and put a dotted line in here. I'm probably not going to be able to do a dotted line. Maybe. Let's see. I have no idea what that was doing. Clearly it's moving my line, or my whole thing. All right, I'll move it back. So I'm going to have to hand draw my dotted lines. Well, it's not going to be pretty, but you get the idea. Okay, put arrows on the end of your line. And then, if I were to drop myself from the top, so I'm parachuting from an airplane coming down onto this line, I'm going to land on this side of the line right here. So here's where I land. There's my lovely self. And then because I'm shading below is where things are buried. This is the mountain I'm standing on. So below is down here. This is where all the things are buried because this is air and sunshine over here. This is below. You can always take this, if you still have trouble figuring out what's above and below, you can take this ordered pair 0, 0. It's got an x value of 0 and a y value of 0, and you can plug it in up here for the x and the y. So if I plug 0 in here, I would get 0. So let's plug that in. And then I would have less than 3 times, and then I'm going to plug in, because my x value here is 0, so I plug in 0 here. Whoops, that would be the wrong thing. How about 0? And then minus 2. 0 less than, well, 3 times 0 is 0, minus 2 is minus 2. Then identify, is this a true or a false statement? Is 0 less than negative 2 true or false? Well, 0 is not less than negative 2, it's greater than, so this is false. So if it's false, then your shading should not be in the direction of the origin, it should be on the other side. So our shading would be down here. So you can either use your test point of 0, 0 into your original inequality, or think of above and below the line. So then I'm going to shade all down here. And so what does all this shading mean? It means that any ordered pair in here is a solution that will make this inequality true. I cannot choose any ordered pair on this dotted line because it's a dotted line. So because it's a dotted line, it means it's not part of the solution, but anything close to that dotted line and below it is. So if I chose the ordered pair, oh, I don't know, we'll choose this one. We'll choose, and that would be 4, 2. So if I plugged 4 in for x, right here, 4 times 3 is 12. 12 minus 2 is 10. So this side is 10, and then I'm going to put 2 in for y. Is 2 less than 10 true or false? Well, that's true. So any ordered pair over here that you plug in here should make a true inequality, and that's what all that shading means. And so we have an infinite number of possible solutions, so that's why we shade. All right, then what I want you to do is not what I just did. Let's see how this goes. We're going to move the whole thing. Oh yeah, it's going to stay here. So hold that thought. Okay, so I finally figured out my technical difficulties. Here we go. What I would like you to do is pause the video, and I want you to graph this on your own. Make sure that you check for dotted or solid line and shade. And then I'm just going to quietly graph it here so that when you turn on the video, you'll just see me quietly plotting the line and doing all the shading. So turn the video off. There you go. All right, so hopefully you have already graphed it and you're just checking your work. So my y-intercept is 1. So I'm going to start on the y-axis at positive 1. My slope is positive 2 over 3. It's always the coefficient of x, or change both signs, negative 2 over negative 3. Then my directions, a positive rise is up, a positive run is to the right, a negative rise is down, and a negative run is left. So I'm going to plot my slope. Okay, so because I have an equals to, I am going to connect this with a solid line. That is not a solid line. Let's remove that. Let's see. How am I going to unremove that? Take this. Yeah, there we go. There, good. All right, let's try this again. All right, so there's my line. I'm going to put arrows on the end of that line. And then, so I have a solid line. And then because it is a greater than or equal to, we are going to shade above. So if I were to drop myself onto the line, I would land here. And if I'm shading above, that means I am in the shading where air and sunshine is. So here is your above shading. And then let's redraw myself. There. All right, and that's it. So hopefully you did well. All right, so let me make this as big as possible and straighten it out. Okay, so the issue with this example, we still haven't graphed a system yet, but the issue with this example is that it is not in the form that I need in order to solve it. I need to solve it for y. So I am going to isolate my y variable. Okay, so to move the 2x, we are going to subtract 2x from this side and subtract 2x from this side. So the 2x's cancel on the left. And don't forget that your 4y is still negative. So negative 4y greater than. Then these two are not like terms because the 12 doesn't have an x. And so since we want it in slope-intercept form, you have got to write the x term first. So negative 2x plus 12. Then here's the key. To solve for y, you have to divide by 4. And then on the other side, I have to divide everything by a negative 4. But if you recall, anytime that we multiply across this inequality sign, which is this is the barrier, anytime I cross here, multiplying by a negative or dividing by a negative, I have to flip this inequality sign. So because I am dividing by a negative right here, you have to flip this sign. Flip. So we're going to flip it before we even do the math to a less than sign. So then the negative 4's cancel, and I have y is less than, because if you don't flip it, your answers are all going to end up being wrong. It's not going to work out. And so then I have two negatives make a positive. 2 4s can be reduced because 2 can divide into both of these. So 2 divided by 2 is 1. 4 divided by 2 is 2. So I end up with 1/2 x. 12 divided by negative 4 is negative 3. And now I want you to pause the video and I want you to graph this line. Think of solid and dotted and shading. Okay, so hopefully you have graphed it. So at this point, your y-intercept, sorry about that, your y-intercept is negative 3. So we're going to start on the y-axis at negative 3. And then my slope is the coefficient of x, which is 1/2, or change both signs, negative 1 over negative 2. And so this direction is up, this direction is right, a negative rise is down, and a negative run is left. So we're going to stair step that slope. So move a couple things here. So we're going to go up 1 and to the right 2. Okay, then we're going to go down 1, but to the left 2. Then you have to think about, do you want solid or dotted line? So I need it's less than, so I have a dotted line, so I'm going to have to hand draw that. And then it's less than, so we're going to shade below. Okay, so dotted line. And then if I am standing, dropped from above down, I'm going to be standing here. So shading below means I want to shade where things are buried. So things are buried below me. And again, you can still use that checkpoint of 0, 0 if you don't like doing it this way. So there you go. Now let's actually solve a system. So here we go. So here we have a system. So we're going to put 2 graphs on 1. So we're going to start off by graphing this one first. So notice that we're missing the y term. Anytime you're missing the x term or the y term, it's either a vertical or a horizontal line. And so it's like, well, which is it? So it says x, and it's no different. You might want to write this down. It's no different than graphing. So it's the same as graphing. X equals 5. So do exactly what it says. You're going to find the x-axis, here's your x-axis, and you're going to place a point at 5 right here on the x-axis. So I'm putting a point at 5 on the x-axis. Then your job is to cut through or go across the x-axis with either a vertical line or a horizontal line. So think to yourself, which one actually goes across the x-axis? Well, this line is horizontal. It goes with the x-axis. That's not the same as going across it. A vertical line would actually cross the x-axis, so that's what we need to do is a vertical line. Because it's greater than, we need to do a dotted line. So I have a dotted line. Going this way. And then vertical and horizontal lines are a little bit different when you're shading. Because it's greater than, we want to shade where numbers are greater than. So just like the number line that we crossed, numbers over here are bigger, numbers in this direction are smaller. So this way is bigger, this way is smaller. So because it's greater than, we're going to shade all over here. So I am going to shade this direction. Okay. All right, so then I need to graph this line. And again, it is not solved for y, but it's close. So we're going to divide by 2. I am not doing anything that would cause me to flip the inequality. So it stays y is less than or equal to. Take the x out of the fraction. We have 3 over 2 x. Negative 4 divided by 2 is negative 2. So pause the video, and I want you to graph this inequality on that same graph on your own, and then restart it. Okay, so your y-intercept should be negative 2. So I'm going to plot a point at negative 2 on the y-axis. And then your slope is 3 over 2, or negative 3 over negative 2, you've got to change both signs. So a positive rise of 3 is up, positive run of 2 is to the right, negative rise of 3 is down, and a negative run of 2 is left. So here we go, up 3, to the right 2, up 3, to the right 2, 3, to the right 2. Then you're going to go down 3 and to the left 2. Because it's equals 2, we are going to connect it with a straight line. So here we go. And I'm going to put arrows on the end of that line. And then here I am dropped off onto that line. And so because it's less than, we are going to shade below the line. So below would be where things are buried, which is all the way here. So let's shade this. I'm going to shade here. And you can see where my shadings intersect here. So this is the intersection of the shadings is all right here. So what I want you to do is where you see the intersection of the shadings, I want you to put a big S or a big X so that I know that you know where the shadings intersect. So that if you pick any ordered pair in this shaded, double shaded region, it will make both inequalities true. So nothing on the dotted line will make it true, but you could choose an ordered pair on this solid line or anything in this double shaded region. Let's continue. So for this one, I want you to pause the video and I want you to try to do this system on your own. Note that both inequalities are set up perfectly for you to solve. You don't have to do a thing, but make sure you watch out. You've got a positive slope and a negative slope. So pause the video. Okay, so let's go ahead and look at each of these lines. So I'm going to graph this one in red. So it has a y-intercept of 1, so positive 1, and it has a slope of 2 over 1, or negative 2 over negative 1. So I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or down 2 to the left 1. Because it's greater than, I've got to connect this with a dotted line. Okay, and then if I drop myself on this line right here, and it's greater than, I want to shade above the line. So I want to shade where there is air and sunshine. So above the line is going to be in this direction here. Okay, then I'm going to graph the second one. I'm going to graph that one in blue here. So my y-intercept this time is negative 1, but my slope is negative. So typically we will start off by taking this negative and pushing it up in the numerator. The negative should only go into one place, not both. So it's negative 2 over positive 3, or change both signs, 2 over negative 3. So you have to go in one positive, one negative direction when you stair step. So I'm going to start with going down 2, but to the right 3. Make sure you have a negative slope. Okay, down 2 to the right 3. And then I'm going to go in the opposite direction. I'm going to go up 2, but to the left 3. Okay, again, this one says just less than, so it's a dotted line. Okay, that's an arrow. Strange but true. All right, so then if I drop myself on the line, I'm going to land on this side of the line, right? So it says less than. So less than means I need to shade where things are buried, and things are buried under the mountain here. So I'm going to shade here. So you can see where my shadings overlap. So I want you to put a big S where the overlap shadings are. And so that's where your solution area would be. Any ordered pair in that area will make both inequalities true. Okay, so then your homework is the odds 1 through 9 on the worksheet posted, but I am going to do question number 3 for you. So stay tuned, and we're going to do question number 3 next. So question number 3 happens to be a word problem, and so let me erase the line I inadvertently just drew. And so I'm going to move this up. I'm going to run you through number 3 so that number 9 won't be so difficult. So if you don't know anything about football, they're giving you some information here. So in football, a kicker can score 1 point for the extra point on a touchdown, or 3 points for a field goal. So that would be important information you might want to highlight. 1 point for the extra point, 3 points for a field goal. Then it says Logan is a kicker for his high school football team. The record number of points scored by a kicker in a single game is 24. So again, that might be important. And then finally it says Logan is hoping to beat this record in his next game. So if we already determine what Logan's record would be, it's a score of 24, because it's number of points, so it's a number of points at 24. How is Logan going to calculate his points? Well, he gets 1 point for every extra point on a touchdown. So an extra kick. That's the end of a touchdown, right? Or 3 points if he kicks a field goal. So I'd have to know the number of extra point kicks he had and the number of field goal kicks that he had. So we have to define our variables first. So we are going to let x equal the number of extra point kicks. And we're going to let y equal the number of field goal kicks. Now, to be honest, it doesn't matter which one of these is x or y. And we are only in the first quadrant because you cannot have a negative number of kicks or a negative number of field goals. So that's just not possible. So we're going to label this line with what we just said it was. So this is going to be extra points. So I'm going to make it EP. And this is field goal FG. So that's our y equals. That looks like a G. It's really a y. And this is x equals. All right, and so then I'm just going to be going by ones. So I'm not going to try to label this, but you might. So then how are we going to figure out Logan's score? So to figure out Logan's score, I would take the number of extra points and multiply that by 1, because that's what they're each worth, is 1 point. I'm going to try to redraw that. So x. Then add to that the number of field goal kicks times 3, because he gets 3 points for each field goal kick. So again, that looks like a G. Should be a Y. And then that, we're going to compare that to 24. So the question is, do we want Logan's points to be equal to 24? Do we want Logan's points to be greater than 24, or do we want Logan's points to be less than 24? Well, if he's hoping to beat the record, we want it to be greater than 24. The question is, do we want it to also be equal to 24? So ask yourself this. If Logan's points were equal to 24, so you had 24 here and you're comparing it to 24, does 24 beat 24? No. So we don't want to put an equals to there. So here's our equation to solve. And so we need to graph it in order to answer part B. So to graph this, it has to be solved for y. So we're going to solve the equation for y. Get the 3y by itself. So subtract x, subtract x. So you get 3y greater than, the x and the 24 are not like terms, so negative x plus 24, squeeze it in there. Then I want to divide by 3 and write what we have left. So I have y is greater than. Take x out of the fraction. You have a negative up top, which has to be a negative 1 over 3x. And then 24 divided by 3 is 8. So our y-intercept is 8, so we're going to count up 8 and plot that. Should be there. Let me double check. So this is 1, 2, 3, 4, 5, 6, 7, 8. So there's 8, and so then I want to go down 1 to the right 3. Okay, so now I want to connect that with a dashed line. Right? Then because it's greater than, if I put myself on the line, I would be landing on this side of the line. So greater than is where there is air and sunshine. So I am going to shade all up in here. So now to answer this question here, it says using your graph right here, give 2 possible combinations for the extra point kicks and the field goals that Logan could score to beat the current record. So anything here theoretically should beat the current record. So I'm going to choose one of them for you, and you can choose the second one on your own. So I choose that point. Why did I choose that point? Because it's in the shaded region. You could choose any ordered pair that's in that shaded region. So find the x value. So the x value is here, so I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that has an x value of 11. And then the y value goes over to here. Oh, that's the 8. I know that's 8 because that was my first point I plotted. So I don't even have to count that one. So remember that our x value is extra points and our y value is our field goal. So therefore, for the ordered pair, so we could have 11 extra points and 8 field goals. Okay, so that's one of them. Then you have to come up with another one on your own. Y'all, good luck on your homework. If you have any questions, feel free to ask.